All right, so should look something like that. So you have a parabola, y equals x squared, that's the red. You have y equals positive 2, which is a horizontal line, the blue one. And then you have x equals 7, which is a vertical line, which is my green. Okay? Okay, so first thing, where is the shaded region? Well, it's enclosed by the first two. Okay, so it's closed by the first two, by the red and the blue. So the closed part would be this little shaded area here. Okay, that's the shaded area there. Okay, the second part is where is it revolving around? What line is it, which of the lines is it revolving around? The blue, x equals 7 or y equals 2?
The green.
The green on mine, right? And might be on yours too. That's x equals 7, right? That guy is x equals 7. This guy is y equals x squared plus 1. And this guy is y equals 2, right? I always put names on there just so that I know which one's which. Okay? So it's revolving around this guy. And this guy is a vertical line, right? This guy's a vertical line. So that's when you have a vertical axis of revolution. So this is a dy problem. Okay, that's how you know if it's a dy problem. So if I had like one of those 3D machine or 3D videos, it would be going around the green. Okay, the green would be the axis of revolution. And you can see the reason we know it's washer method, that's a great question. Why is it washer method? Why is this one washer and not the disk we did the other day?
Because it's not directly touching it.
Exactly. The shaded region and the axis of revolution are not changing, or not touching, sorry. There's daylight in between them. Now, if y equals 2, let's say y equals 2 was the axis of revolution, then it would be a disk method, okay? Because the y equals 2 is touching the shaded area, okay? All right, so let's set up our equation. Volume equals pi, radius 1, or big radius minus little radius, a dy. This is a dy. So what do we know about dy setups? What's different about them when we're talking about this, the
Y values and stuff like that.
I only can put y's in here, right? If there can't be any x's anywhere in here, if it's dy, right? It's with respect to y. So that means it's kind of y's world, right? So only y's are allowed in there, okay? Okay, so next thing we got to do is find out what our big R is, our big radii is. Okay, so remember, we always start on the axis of revolution. So I'm going to start on the green. Usually I start below or above the shaded part, right? I can't do that right now because there is no above or below the shaded part. So I'm going to start on the right side of the shaded part. So anywhere on the right side of the shaded part, make a dot. And I'm going to go left this time because that's where the shaded part is, right? I'm going to go left until I get to the other side of the shaded. That's big R. Big R goes farther than little r. All the way to I hit the other side. That becomes big R.
Mr. Flores,
Uh-huh.
how would you calculate it though? Because it's going on to the same parab.
It's a great question. We're going to get to that. Yeah,
Okay.
that's a great question because, yeah, let's do little r. Little r, yeah, I like what you're thinking because you're thinking ahead. Little r goes, but it goes to the same function, right? So great question, Macy asked. Well, it's going to be, both are going to be green minus red, right? Isn't it just going to cancel out? If I have green minus red, and won't they cancel out? No, they won't. And there's a reason why, and I'll explain right now. I'll explain it in a second. Okay? Okay, so everything I put in here, right, has to be with a y. It can't be with an x. So look at your equations. Is there any of them that have an issue with that? y equals x squared plus 1, right? So that one I'm going to have to solve for x. So I'm going to have to set up and do y. Yeah, so it's going to have a square root instead of a squared, right? So y equals x squared plus 1, right? So I subtract 1 from both sides. Take the square root of both sides. What happens when I take square roots when I'm solving, though? You get a plus and a minus, right? I get 2 answers. So it's y minus 1, right? Okay. So that's where it comes from. Yeah, so one of them is going to be a plus, one of them is going to be a minus. Yeah.
Thank you.
Okay, yeah. So we got to decide which side is the plus, which side is the minus. Well, anything to the right is going to be plus, right? So this side over here, positive, and this side over here is the negative part. Yeah. Okay. All right, so let's start with the big R. Big R extends from, so we go right to left. We always go right to left. So big R extends from 7. It already says x equals, so we're good there. So we're going to go 7 minus. And then the red, right?
It would be negative.
So it's going to be the negative one. Yeah, it's going to be the negative one. It's going to be minus a negative.
It would be 7 plus.
Yes, exactly. So it's going to be 7 plus, right? The other one is going to go from 7 to the positive one. So it's 7 minus square root y minus 1. Yes, yeah. Okay. So next thing is bounds. So remember, with these, bottom bound, top bound, only y values. So what's the bottom bound
1.
for this one? 1 and 0, right? 1 and 0. So 1 is the, so sorry, negative, or no, positive 1, that's right.
1 and 2.
Yeah,
1 and 2, yeah. You guys are right, 1 and 2. Okay. Got everything we need. Go to the calculator, see what you get. That's what I got, yep. Verify that you guys got 58.643. It's good practice to use so that you know how to.
We could just put x, right?
Say it one more time.
Since the calculator doesn't have y, we could just put x as the
Yeah,
variable.
as long as the variable's all the same, the calculator's happy. So yeah, sometimes, like I said, for dy's, it's the same. In your calculator's mind, it's the same as dx. But in reality, it's dy. So yeah, in your calculator, you can change dx to dy, but then you got to make sure everything else is y. Or you can just leave everything else x. Yeah. In your calculator's mind, everything is dx. dy doesn't exist. Well, we know it does exist, right? So that's why it's a calculator. It's not, it works on an algorithm, doesn't have a brain. Okay? All right. Okay, so let's look at number 6 now. Let's look at number 6.
And it's because you put -1.
So 6 has 3 parts. 6 has 3 parts to it, A, B, and C. It all deals with the same graph. The graph's the same. Okay? So you already got a picture. So do you need to put it in your calculator? You can if you want, but I mean, you got a picture there, so, right? So 6a says find the volume. Okay, so let's say the graph. The graph has 3 parts to it, 3 graphs. Y equals 2x squared, that's the parabola. Y equals 0, that's the x-axis. And x equals 2. Okay? So, first thing we got to do is I want you to find, so this one I want you to do on your own. Find the volume of the shaded part if it's revolving around the x-axis? Is that disk or washer method? Disk. So you're only going to have one R. You're not going to have big R or little r. You're only going to have one R. It's the same way, right? It's the same way. You do it the same exact way that we did before. No, there's no difference between the way we did it before and the way we're going to do it now. So there's only one R, and it's squared. And this is dy or dx? Dx, okay? Because we're revolving around a horizontal axis, yeah, line. Okay. Okay, so how did we find little r? It's the same way we found big R, right? Except there's no above and below. We just start, make a dot on the x-axis, because that's where we're revolving, right? And go up until you're out of the shade. That's R. There's only one R. There's no big R and little r, there's just one R. So we do the same, top minus bottom. So the top dot, which function is the top dot on? Y equals 2x squared. Which function is the bottom dot on? Y equals 0. Okay. Bounds, left bound, x value, right bound, x value. 0 to 2. 0, 2. What do you get? When you put it in your calculator, you don't have to put the minus 0 part. You can if you want. It doesn't do anything, but yeah. What'd you get? That's what I got. 80.425. Okay. All right. So what I want you to do now is do B and C. Do B and C. Okay? I want you to do B and C. I'll give you about 10 minutes or so. Do those on your own. I'll give you the answers. I'll put the answers on the board, and then we'll do them together, and we'll be done. So if you go, get as far as you can. So if you can't actually get all the way to solve them to get those answers, we'll go over them. But just go as far as you can. So with 6b, the axis of revolution is the y-axis. That's why it's dy, we said that. Okay. It's washer method because there is daylight between the shaded area and the axis of symmetry. I know they touch down here, but there's a whole bunch of not filled in stuff here. Okay, so it's washer. So again, we always start, make a dot on the axis of revolution. This one, where is the shaded part? It's to the right. Axis of or the shaded stuff is to the right, so I'm going to need to go to the right. And I'm going to go to the right until I'm out of the shaded area. So I go and I go in, and then there I stop. I'm out of the shaded area. That's big R.
For C, I got 0.658. Or I got 187.65.
That's good. Yeah. Little r goes until you reach the shaded area. Little r. But remember, it's always right minus left. Right dot minus left dot. So even if we went right or left, it's always right minus left. So the right dot is at x equals 2. The left dot is at x equals 0. Okay. The other one, the right dot is at y equals 2x squared, right? The left dot is at y equals 0, or x equals 0. But again, this guy, we're going to have to do one of our things because it's not in terms of y. So we have to solve for x. Okay, so I have to solve for x. So y equals 2x squared. So I divide both sides by 2. And then I take the square root. So I get x equals plus or minus the square root of y over 2. For our side, because we're only on the positive x, positive y, it's going to be positive. We're going to use the positive one. We're not going to have to use the negative one for this one. So it's going to be that guy, positive square root of y over 2 minus 0. Bounds go from top to bottom. So the top, you can verify using your calculator because they tell you. You could just say you could put in your calculator, where do y equals 2x squared and x equals 2 cross, and it's at 2, 8. And then 0, the x-axis, 0 to 8. And when you put that in your calculator, you should get 50.265. Okay. All right. Last one. Same setup, but now it's revolving around y equals 8. That, again, y equals 8 is a horizontal line, right? So this is a dx again. Okay, so this part is revolving around. Is it a washer or is it a disk? Washer again, because there's daylight between the blue line. Even though they're touching up here, look at all this that's not touching. Every part of the shaded part has to touch the axis of revolution, and this one's not. Only a little piece of it is. Okay, so it's washer. Oh, also another question. Another question I get is, what if I forget? What if I forget which one it is, disk or washer? What do I do? Here's how you do it. Watch. Let's go to a washer or a disk method. We just did a disk problem, didn't we?
Yeah, it was 2.
Number 1, right?
Number 1.
Is it possible for me, what would happen if I made another little r on this one? Where would it, how long would the segment go from? 0 to 0, right? Because there is no, because right, when we do a line, we go from the axis of revolution to the end of the shaded part, right? That's big R. Little r is from the axis of revolution to the beginning of the shade, right? How the heck do I do the beginning? How do I make a segment that goes from the axis of symmetry to the beginning? It's just a dot, right? And a dot has no length. So little r would be 0. So it's technically the same formula. It's technically the same formula. So what if I accidentally do a washer, but it's supposed to be disk? You should get the same answer. If you do it correctly, you should get the same answer. Now, I've had some people try to draw another line that goes like here, and that's wrong. That's just all wrong. But this is actually, this method, this equation, this formula right here will work for disk and washer. Okay? So if you can only remember one, remember that one. But you can also put them both on your card, so you don't have to remember them. Okay? Okay, so I have to start at the axis of revolution. So the axis of revolution, let me write this down first. Volume equals pi. Axis of revolution's way up here. So I'm going to go, this time I'm going down until I stop, until I'm out of the shaded area. That's big R. Little r goes until I hit the shaded region. Big R should always be a longer segment than little r. What are the bounds for this one?
0 to 2.
0 to 2 still, yeah. Not 0 to 8 because that was for dy. This is dx. 0 to 2 because it's the same shaded area still. So again, top minus bottom. It's always top dot minus bottom dot. So the top dot is at 8, so it's going to be 8 minus 0. Or just 8. 8 squared is 64. The other one is going to be 8 minus 2x squared. And you're done. Okay. So when you plug that into your calculator, I got 187.656. Okay.
That was the same answer technically, just 0.2 off.
Yeah.
I put 2x squared minus 8 instead of.
No, that's
actually,
right, yeah.
but I still got-
6.5, you got 6.58?
Yeah, I got 6.
That's
well,
fine.
I got 657 something something something.
Yeah, that's You're good. Okay. Alrighty. Okay, so we have one more